A rocket is rising vertically at a rate of 5,400 miles per hour. An observer on the ground is standing 20 miles from the rocket's launch point. How fast, in radians per second, is the angle of elevation between the ground and the observer's line of sight of the rocket increasing when the rocket is at an elevation of 40 miles? Notice that velocity is given in miles per hour and the answer asks for radians per second. Okay, so that last piece we're going to have to save until the very end, and we're going to get our answer in hours, and we'll have to change it to seconds. Okay, so this is a related rates problem because we want to know how fast something's changing. And so to do that, we start with step 1, which says draw a picture. So I have a rocket over here, and it's going up at 5,400 miles per hour. Let's call this Y. And then I have a person standing on the ground over here, and he is 20 miles from the rocket's launch point. And that 20 miles is never changing. He's always going to be that far away. How fast is the angle of elevation? So he's looking at it here, and let's call that angle theta, between the ground and the observer's line of sight of the rocket, increasing when the rocket's at an elevation of 40 miles. Okay, so here's my picture. Step 1, draw a picture. Step 2 says make a list of what you know. Okay, so I know that dy dt is changing at 5,400 miles per hour. I know that I'm going to use y to be 40, and I'm looking for d theta dt. Okay, so let's make an equation. I have theta, I have y, and I have 20. So I have an angle, I have the opposite, and I have the adjacent. So I'm going to use tangent. Tangent of theta is opposite y over adjacent 20. And remember, I can plug in that value for 20 because it's never changing, but I can't plug in a number for y because y is changing. Okay, and then let's take the derivative with respect to time. So I need to use implicit differentiation. Derivative tangent of something is secant squared times the d theta dt, derivative of the inside. Derivative of y over 20 is 1 over 20 times dy dt. Okay, now we have to plug in what we know. The problem is we don't really know what theta is. So at this particular moment in time, we have 20, we have 40, we have theta. We can find that third side using the Pythagorean theorem. So if you use the Pythagorean theorem, you can find that third side to be 2,000. 20 squared plus 40 squared is d squared, for instance. Okay, so I'm going to plug in everything I know. The d theta dt, to get rid of secant squared, I'm going to multiply both sides by cosine squared. 1 over 20 cosine squared theta dy dt, because secant is 1 over cosine squared. Okay, and then I plug in what I know. So I know that the cosine, here's my triangle to describe theta. So the cosine is 20 over square root of 2,000 squared. They gave me dy dt up here, 5,400. Okay, put that all in your calculator, and you get d theta dt is 540, and that's in radians, because it's an angle, per hour. Okay, remember, they want the answer in seconds. So to get from hours to seconds, you're going to divide by 3,600. So d theta dt is going to be 0.15 radians per second. So this angle of elevation is changing 0.15 radians per second.